And hello again, my little mathematicians. We are continuing on with reviewing Mod 16, or Unit 7, by looking at the study guide in our textbook. So please follow along on page 489. Again, page 489 in your textbook. And let's take a look at example 4. And again, always you can feel free to try the problem on your own. Hit pause, and then after you finished it, unpause it or hit play, and then check yourself. So if we take a look at example 4, it says the coach recorded the time it took 14 students to run a mile. The times are as follows: 9:23, 8:15, 9:23, 9:01, 6:45, 7:20, 9:14, 6:21, 7:12, 7:34, 6:10, 9:15, 9:18. Use the data for example or exercises 4 through 5. Give an example of a statistical question, so in other words, an answer that you can get multiple answers from, and that you can qualify, or quantify, I should say, that you could answer from these data. Describe how you might answer the question. So a question that could have produced this data set would be, what are the mile times for LRMS students? So that's a question that you could have asked that could have produced that specific data set. Now let's use those numbers to answer the next question. It says we want to use this data to complete the frequency table right here, then use it to make a histogram right here. Okay, so if you think you can do this, go ahead and pause and then come back. If you're back with us, they're doing it basically by the minute. So from 6 to 6:59, so let's do 7 to 7:59, and then 8 to 8:59, and 9 to 9:59. So how many people did from 6 to 6:59? If we take a look up here, that was 1, 2, 3, 4. So 1, 2, 3, 4. From 7 to 7:59. 1, 2, 3. It looks like just 3. From 8 to 8:59. I see 1, just 1. And from 9 to 9:59. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Notice that when I get to 5, I draw a diagonal slash. It just makes it easier to count the tallies. All right, so these are the different amounts. So how many times was it from 6 to 6:59? 4 times. So go up to the 4 mark and draw a bar graph. From 7 to 7:59 happened 3 times, so go to the 3 line. And again, we're going to draw a bar graph. And then from 8 to 8:59 was only once, so draw a bar graph that goes up to 1. And then from 9 to 9:59, we're going to go all the way up to 6. Ignore the random bell going around. That would be the cat. Okay, so right here, this is a histogram, or I like to call it a bar graph, but the bar graph is representing how many times each data value happens. And unlike a bar graph normally only has one number down here that it's representing, versus a histogram can have one data value or a range. So like from 6 to 6:59 instead of one singular answer. Okay, and then we use a frequency table to sometimes help us graph our histogram. All right, let's go ahead and look at number 6. It says, the data shows the distances driven by Juan on different days. Use the data for exercises 6 and 7. It says find the mean, the median, and the mean absolute deviation, or MAD value, of the data. If necessary, round to the nearest hundredth. All right, for the mean, we are going to add all those data values. So you have 12, 9, 7, 7, 11, 10, and 7, and that's 1, 2, 3, 4, 5, 6, 7 numbers. So I'm going to divide by 7. Go ahead and add all those together and you get 63 divided by 7. So you have a mean value of 9. For the median, put them all in order. So you had 7 3 times, 1, 2, 3, and then 9, and then 10, and then 11, and then 12. And I always count, there was 1, 2, 3, 4, 5, 6, 7 numbers in my data set. 1, 2, 3, 4, 5, 6, 7 numbers in my data set, just to make sure I didn't miss any. Okay, once they are in order from least to greatest, you cross off from beginning and end until you get the middle number. So beginning, end, beginning, end, beginning, end. My middle value is 9, so it has a median of 9. Now to find the mean absolute deviation, depending upon the year, we will sometimes do that, sometimes we won't. But you guys do, regardless of the school year, we always cover mode and range. So what's the mode and range? If you said the mode was 7, you're correct, because that's the one that happened most often. And then your range is the biggest minus the smallest, which was 5. Okay, so those two things would always come up, the mean absolute deviation or MAD value, depending upon the school year we do it. So I'm just going to show you the answer really fast, or if you want to try it, if it's a school year that we did it, press pause, then unpause it when you want to check. Okay, for the mean absolute deviation, you take each individual data value, 12, 9, 7, 7, 11, 10, and 7, right here. And you find the distance from the mean. Well, the mean value was 9. So how far away is 12 from 9? 3. 9 from 9 is 0 away. 9 and 7 are 2 away, 9 and 7 are 2 away, 11 and 9 are 2 away, 9 and 10 are 1 away from each other, and 9 and 7 are 2 away from each other. So you find the distance each data value is from the mean, and it's called the mean absolute deviation. So you take the mean of those. So now add all the deviations together, and then divide that by how many numbers there were in the data set. And you get a mean absolute deviation of 1.714. It did say round to the hundredths, so underline the hundredth spot, and that 4 tells us 1 to stay 1. So the mean absolute deviation rounded to the hundredths is 1.71. For number 7, it says, suppose Juan drives 33 miles on a different day. How would this new value affect the mean of the data? How would the mean absolute deviation change? And then assuming that this data value is added to the data, which measure of center, the mean or the median, would you use to describe the typical number of miles Juan drove each day? And explain your reasoning. So first of all, let's take a look at what my new mean would be. So here's the original numbers, but then we just added 33 into it. And now instead of having 7 data values, we have 8. So when I do that, I add all those together, divide by 8, I get a mean of now 12. So my old mean was 9, my new mean is now 12. My old median was 9, my new median, I have all the numbers in order, except this time I added 33 to the data set. Cross off, cross off, cross off till you get your middle number. It's between 9 and 10. Notice last time it was an exact number in the middle because there was an odd number of numbers in the data set. This time there's an even number of numbers, so it's between two numbers. And so you go halfway between 9 and 10 is 9.5. So my new median is 9.5. Okay, my old MAD value was 1.71. My new MAD value, okay, here's all the numbers, except I included 33 this time. And my new mean, instead of being 9 like last time, my new mean is 12. So how far away is each individual value from 12? Okay, well 12 is 0 away from 12. 12 is 3 away from 9. 12 is 5 away from 7. 12 is 5 away from 7. 12 is 1 away from 11. 12 is 2 away from 10, 12 is 5 away from 7, and 12 is 21 away from 33. So these are all the absolute deviations, like the absolute value of it. Because notice how 9 minus 12 is technically negative 3 versus 33 minus 12 is a positive 21. But you take the absolute value of each of them. That's where the absolute comes from. It stands for absolute value of the deviation, the distance each value is from the mean. And then you're going to take the mean of those numbers. So add all those together and then find the mean of it. There was 8 numbers that we're dealing with. So my new MAD value is 5.25. Remember how we said in an earlier note that the bigger the the bigger the MAD value, the more spread out your data is. And the smaller the MAD, then the more closer together your data is. Well, yeah, last time these were all pretty close together versus this time 33 is way far away than all the other numbers. Your next biggest number is 12. 12 and 33 has a huge gap. It has a distance of 21. So I probably wouldn't want to use the mean to do my measure of center. Whenever you have an outlier, it's best to use a median for your measure of center, because when you cross off, that 33 is like it wasn't even a part of the equation, and you find between 9 and 10, which is like the vast majority of your data. And look, the difference between the last mean was 3 versus the distance between the old and new median was only a half. So there's another indicator to show you that whenever there's an outlier like that 33, you should use the median rather than the mean to do the measure of center. Okay, so for the problems that we did, mean, median, and if you added in mode and range, and when we reviewed the histogram, hopefully you got all of those right. And then if it was a year that we did MAD, hopefully you got those right, or you learned something new. If it was a year we didn't cover it, you got a little sneak preview of something that's coming up in 7th grade. All right, congratulations, my little mathematicians, at conquering the statistics units.